it will be given to you post the I hope it is already available to you guys. If it is not there, it will be provided. Okay, so this was all about course curriculum. I would now like to start this session for DevOps introduction and why do we need DevOps, what was the need of DevOps in IT technology. So I would actually start this by asking a simple question to you guys. Does anyone of you have any idea about what is DevOps, or why do we eh, need DevOps? Any one of you can raise your hand and maybe unmute yourself and explain. If anyone, if you don't have any idea, that is fine. That is absolutely fine. That is why I'm here to tell you all. But if you have any idea, I'm happy to listen to you guys. Okay, so I'll take it as a no prior knowledge of DevOps. Fine, no problem. So let me start this. Forget DevOps for the time being. Let's start this session by talking about how software development starts, how software development works. Okay, so suppose one of my friend owns a pizza shop. Okay, he has a pizza shop. Now, with time, the on the pizza shop, the customer increase. Okay, now he's not able to fulfill all the requirement of the customer from the shop itself. He wants to go his business online. He wants to take his business to online. Maybe he wants to develop a website through which users can, order pizza, or maybe he wants to develop a mobile application through which users can, uh, order pizza. So what he did, he approached me. I am his friend. I own a software company which creates software. So he approached me and told me, "Hey Gaurav, I want to build a website for my business." Right. So okay, I spoke to him. I am a managing director of my company. I spoke to him. I took his requirements. Okay, what are the requirements he had? Oh, and so he told me that that the web page should look like this, and there should be the color of the page should look like this. I want these things in my menu items. So all the requirements we have gathered. Okay, based on his requirement, I approached to my project manager. I have a project manager in my company who handles a team of software developers. I approached him. Okay, I told him that there is a client who wants to build a website for his business. So the requirements are now uh, shared with the developers. So developers starting to design that blueprint of the website, how they are going to make it happen. So this whole process of designing, compiling, designing. So this fits in a role called software development life cycle. So in software development life cycle, we we used to have three different models. In earlier 2000, there was a traditional model that was followed to build that website and to deliver it to the customer at the end. Okay, so traditionally this was the approach which was followed. uh, I hope my screen is visible and you guys will be able to see waterfall model. It was a very popular model at the time of earlier 2000. All the companies, almost all the software development companies, used to work on this method whenever they were asked to build any kind of software for themselves. Fine. So how does this waterfall model works? It works in a different phases. So requirement gathering and analysis is the first phase of the model. Designing is the second phase. Implementation of the design is the third phase of the model. Testing of the implemented product is the support and deployment and then maintenance. So if you see, if you let me quickly copy it to the paint and So if you see here in this model, it is going like this. Okay, the building of the application, it goes like from top to bottom, like a waterfall. Okay, so first thing, we will gather the information from the client. We will gather all the requirement, what kind of work he wants, what kind of website he wants. Then we will move to the designing phase of the where we will sit with our architect and he will design a blueprint of our application, that how developers are going to design this or how we are going to work on this. Then after designing, there's an implementation part in which the actual coding starts. Okay, as developers start to work on the modules and the design that they have created. After they have built the design, after they have done the code is then compiled and artifact is generated, and that artifact is again now tested for all the different testing scenarios that we have for load testing, performance testing, sanity testing. After it has passed the testing, after the testing part is done, then it is finally deployed to the production environment and made live to the customer. So this was the model which has multiple issues with it. Okay. So although it was the very first model, so developers thought that this is not working out. Why it is not working out? Because every step is dependent on the previous step. So the next the design phase in dependent on the requirement. The implement phase is dependent on the design phase. Until and unless implementation is completed, testing cannot be done. So it is dependent on the implementation phase. So every stage in this model is dependent on the previous stage. Fine. So it what it did, it was actually wasting a lot of time and resources as well. How? So suppose that my architect is busy in designing. The first phase is needs to be complete uh, in this model. Then only we'll move to the next phase. I have people who will. So I hope you guys have heard about system admins roles, okay, or the build and release engineers. So these teams sits here in the deployment part. Until and unless the developer will give him the code, they will sit idle. They will not do anything, right? They have to. So it is making uh, a, a resource utilization not in convenient way. So this was the very first issue with this model. Second, it was very time consuming because every stage is taking a lot of time. It might used to take 1 to 2 years, minimum 1 to 2 years to complete the whole project. And the third drawback was that once one stage is completed, it is not possible to go back to the previous stage if they want to change anything. Suppose that my friend now came back to me after 4 months after I've done the designing part or my implementation is also done. He came back to me and he told me, "Oh, wait, I want to uh, involve one more chatbot option in my website so that people can talk to me if they have some kind of issue." So now I cannot move back to implement state and take his request. I have to go back to the requirement state again. I have to redesign that product, that blueprint again, and then start implementing. So this used to take uh, ages, right? And there was a resource limitation of resource utilization as well, because until this is done, the next part cannot be completed. So there, it has multiple drawbacks. So and the main drawback was it as it used to take 1 year, 2 years. Some suppose that now your product is finally ready, and you want to deliver to the customer after 1 year. You go to the customer and say, "Hey, your product is ready." So what customer will do now? He says you, "No, I don't want this product anymore. My business is all already shut." So you have wasted your 1 year, you have wasted your money, you have wasted the implementations, everything, and it is not working out. The product that you have built is no more required. So it was a loss of businesses. So this waterfall model has a different issues, right? So as you can see in the slide I have mentioned, high amount of risk and uncertainty. So as you're not talking to the customer in between, you're talking to the customer at the end of the rep. So there are high amounts of risk available that customer will accept it or he will reject whatever you have built. Not a good model for complex and object-oriented projects. So it is it was not a very good model for complex projects. So is the project which are high in complexity, okay, which needs multiple catalogs to be built, multiple items to be built as a part of website or mobile app. Not suitable for the projects where requirements are at very moderate to high risk of changing. So as I told you, so you don't know, after 6 months your customer changed his mind. Now he don't want this background color. Now he don't want the menu items to be look like in this format. He wants multiple other things, right? So these are the some drawbacks which led to another model of software development, which was agile. So what software developers thought that no, it's not going to work. We need to think something else. So then there comes another method called as agile. Any questions on this waterfall model, guys? Okay, I'll take it as a no. Now comes the next model in the software development lifecycle, which is agile methodology. So what software developer or what the company started to work on, they instead of developing a full-fledged project and delivering it to the customer at the end of the completion of the project, they divided this project, the whole project, into multiple smaller iterations. Okay, there was a sprint that was uh, and that started to work. I mean, there was iterations. The whole project was divided into small chunks, small pieces, and there was a um, design and development of those small pieces on a particular time frame of period of time. Like the iteration could be 2 to 8 weeks. So what does it mean by that? That we we will divide the whole project that we want to build a website for pizza. So what we will do is we'll start by building the main page of the project, and we will what we'll do, we will try to deliver it to the client once it is completed in first iteration, right? So we'll design the blueprint of the project, then we will develop it, design it, and then we will deliver it to the customer within 2 to 8 weeks of time, whatever the duration that you guys have, I mean, the developers have thought of. It could be 2 to 8 weeks of time. So, and the second iteration as well, and the third iteration as well. So, the designing of the full project was done in iterative way, in smaller chunks. So, what was the benefit of it? So, first of all, customer communication was the first benefit. So as we are delivering some part of the project to the client within 2 to 8 weeks of time, within our first iteration, customer was very much interested in, okay, so something is getting built for me. So there was a customer satisfaction, a kind of customer satisfaction that was going on. Second, if there is any kind of change which is happening, which customer want, okay, so he can straight away tell in the first iteration or the second iteration. Once we design and build the first iteration and show it to the client, that if the client wants any kind of change, we can pop up with that change in our second iteration. Okay, which was not possible in the waterfall model, right? Same goes with the third iteration as well. So like this, we started to build the projects with the agile methodology. So fine, everything is working fine. Now the developers are happy, and we are now able to deliver the project within 6 to 8 months of time. So everything is working fine. Business is going good. So what is the problem with the agile then? Why do we need to move to DevOps? I mean, why does DevOps come into the picture? Everything is working fine. So I'll tell you what was the problem. The main problem was that we were working solely on, we were talking about the development of the project. We were talking about the developer's perspective of this project in this model. It is a more of a developers defined, method. So it do not talk about anything of the deployment team. What about the deployment team? There's a deployment. So once the software is built, this software needs to be deployed to the server, a web server, you can say. And because at the end of the day, customer has to access this web server through website only. So this has to be somewhere deployed, and that deployment has to be done on a web server. And who creates those web servers? System admins, operations team. So you will need to tell them that, okay, I have built a website. I need to deploy it. I need a server with such and such functionality, with such and such requirements. For example, suppose developers have built the code in a .war file. I'll take an example of Java-based application. It can be built in any language, but let's take an example that software has built this uh, website in a Java-based language. So I want a Java config, a Java compatible server on which I can, deploy my code, right? So now developers will have lot after, because it is in an iterative way, and we are making the sprints. We are making these sprints in every 2 to 8 weeks, and we have a new deployment in every 2 to 8 weeks. It becomes a very hectic task for the system admins to cope up with these requests very often, right? Because in every 2 weeks there will be a new requirement to deploy the new code that they have built, and it will require a lot of approvals. Okay, it will require a lot of manual intervention. It will require a lot of manual configuration changes. Okay, so this designing part, the application development part was very good in this methodology, but the deployment part or the operations part was not taken care at all. So suppose what happened is, now my developers has built the code. Okay, he has designed the first iteration and he's very happy. Okay, I built the code. It's working fine on my machine. Now I will ask operations guy to deploy it on the server. Create a server with such and such RAM, with such dependencies, and deploy it to the server. So the developers thrown the code to the operations team. Hey, operations guys, just deploy it. So what happened in then the operations guy came back to this developer team and told him, wait, this code is not working on my machine. This code is not working on the server. So he told this developer team told checked again why the code is not working, and it started to work again on his server. So then in that case, what happens is there's a blame game that starts. So it's working on fine on my machine. It's not working fine on your machine. There has to be some issue with your machine. You have to fix it. But what was the main issue? The communication problem was there. The development team did not tell this operations guy that you have to install such and such dependencies because it's a Java based application. It requires OpenJDK to be installed priorly on your machine, which operations team would not have any idea about. Why would they have any idea about it this one? So this lacks in communication as well. Okay. And there happens a delay as well. There happens a lot of bugs as well. So whenever he tries to deploy this artifact on server, there were a lot of bugs, there were a lot of errors. So this blame game started happening here in this agile methodology. So So to overcome this situation, where there comes the real hero, which is DevOps. So what DevOps basically do, it 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 brings together both the teams which were working in silos earlier to work collaboratively and with effective communication. So developer needs to communicate well with operations team and tell them that this is the dependency, this is how my server should look like, this should be the configuration, and ops team should be able to communicate same with the developers team as well, whatever they require at the operations side. So it bridges the gap between dev and ops team. There is a continuous collaboration and there is a continuous talk, you can say, happen between both the teams. And now the delivery of the project is is done in a much more efficient way and effective way. And we are able to deliver a good quality product to the customer within a very, very shorter duration of time. How does it actually achieves it? Let me, okay, I'll pause it. I'll pause this for a minute and I'll wait for the questions. If you guys have any questions about Agile or Waterfall, then we'll move to talk about DevOps. Okay, fine. I'll take it as a no. Uh, Fine. So how does DevOps come into picture now? How does DevOps solve these problems? So, so dev challenges was waiting time for the code deployment. There were lot of waiting time earlier for the code deployment. And how does DevOps provided the solution? With the continuous integration of the product. So in DevOps, we speak a lot about CI and CD, continuous integration and continuous deployment. So we will talk about more in more for this continuous integration and continuous deployment. So here I just wanted to show you guys what are the challenges that was faced in operation and how DevOps fulfilled it. What are the challenges faced by developers? Pressure of work on old and pending and new code. So there were a lot of, I mean, they used to work on a lot of previous codes. They have a lot of iterations to work on. Okay, and they do not, as they are not doing a integration timely, so the code gets on, compile. There was huge burden on them to compile long source code, right? So that source code is actually again now it compiled. You can say it's 1,000 line of code is there, and which was very prone to errors. If it gets compiled within if it does not get compiled within timely manner. So con- to overcome this long code uh, scenario, the DevOps methodology provided continuous integration, right? And how does it fit in operations work? So operations guys, they were failing to maintain uh, production servers all the time. They have different you can say different requirement at every different iterations in agile methodology. So uh, they need to maintain a lot of servers. So every time a code is built, every time there's a new build that happened, it has to be deployed on a new server. So which in turn created multiple thousands of servers, right? So these servers were very, crucial to maintain. They were very hard to maintain. So DevOps provided something called containerization or virtualization of the servers, through which we can build servers in seconds, in minutes. Instead of maintaining the hard physical server, we can create a virtual machine. We can make use of cloud, AWS cloud, and we are ready with the server. We can deploy the code within seconds. Okay, so the tools to automate infrastructure at operations level were very limited or not effective. So earlier they used to use write shell scripting. Suppose that one person who has written the shell scripting leaves the company. Now the next person will come. He will not be able to understand what he has written because the shell scripting is written in his own way. He knows what kind of variables that he has defined, what kind of scripting, what kind of scripting has he done. So these were some issues that was overcome by this DevOps, DevOps methodology of software development. So what is exactly DevOps? So DevOps is not a role, it is not a team, uh, it is not a tool, it is just a way of working, the new way of developing and delivering software to the customer. Okay, it is the way the people think of a software development life cycle, right? It is a new way of working in which we always talk about continuous integration, continuous deployment. We will talk about more for continuous integration and continuous deployment now. So these are some tools that we use in DevOps, okay, in day-to-day life to to build this pipeline called CI/CD. So for the planning and for the integration purpose, this is mainly used by developers. It's not mandatory that only developers will use it. Every team who writes a code, maybe infrastructure guy who writes a code for Terraform, he needs a Git, right? He also puts the code in GitHub. So these are the some tools that are used on like for the continuous development, which is Git, Bitbucket, okay, GitHub. So we will be learning GitHub in this course. There's some continuous testing tools. So once the code is built, it has to be tested for the qualities of the code, how the developers has built the code. So it has to pass certain tests, right? So that testing can be also be done through this pipeline, and we can use Gradle, JUnit, okay. Maven we use as a build tool. We will be studying Maven in this project, right? Once the testing is complete, then it goes to the deployment, continuous deployment. For the deployment, we can use Chef, Puppet, Docker, Ansible. So we will be learning Ansible in this course. We will be using Jenkins as a complete CI/CD server. Okay, we'll be learning that. And then there's a continuous monitoring that is happening. So you see, continuous is the main keyword here. Everything is done in a continuous way, right? So we are continuously building the code. We are continuously integrating the code with our uh, GitHub repository. We are continuously pushing that code build to the testing server. The continuous testing is there, so the early we can catch the errors in the code at a very early stage, and if there are errors in the code, they can be given straight away to the developers, and they can fix it and then again start the build process to test the code again, right? There is a continuous deployment that is happening. So once the code is built in the build server, Jenkins build the code. There's once the code is built, so there's something called artifact, which is generated after the code is built actually. Okay, so that artifact is nothing but a compiled you can say compiled package of the source code that developers has built. So what happens is whenever there's a software that has to be built, or software or website that has to be built, so developers only write the code in any of the language, programming language. It can be Python, it can be Java, it can be any other Go language like Go, right? Once they write the source code, uh, we need to package that code with all the dependencies, right? We need to build that code so that it makes sense out of that code, and it creates an application out of that lines of code that they have written. So that is called source code building. Okay, after the source code is built, it will generate something called artifact. Okay, artifact is nothing but packaged archive of your source code, right? And that artifact is then deployed finally to the web servers through which we see our websites, right? So that is actually artifact that is running. of the code that has software developers has written, right? So this is how the DevOps, DevOps methodology used to overcome this uh, uh, drawbacks of agile, and it has gained lots and lots of popularity in the past 8 9 years, and every company is moving to the DevOps, DevOps culture. So they are hiring engineers who have good knowledge on DevOps tools. Okay, who can create CI/CD pipelines, who can do who can create automation of almost every way possible, like automation of infrastructure, automation of configurations management, so everything, right? So these are again some tools. These are again some tools. In the planning phase, we use Jira, Slack. These are tools basically used by developers. And in the coding phase, we use GitHub. PyCharm is the code editor that most of the developers use to develop. Yeah, I mean it's the ID. They can the developer can work on any ID based on the requirement. VS Code is also there, right? So for the build, we use Terraform, Gradle, Docker. For the continuous testing, we use JUnit, Selenium. For the release, we use Jenkins. So all these are the tools you can see here, right? As for the, I've taken the screenshot from the Naukri.com. Okay, so these are the DevOps stages that generally goes whenever you start in any company, or you can say you start building of any of the project. So there are multiple developers sitting on the different part of area maybe, and what they used to do, first they write the code on their laptop, and then they push this code to the central repository, because they cannot keep the code locally on their laptop. For suppose that the laptop crashes, okay, so they have to maintain this code somewhere uh, in a centralized repository called version control, or SCM. We will deep dive into this one once we start with Git. Okay, they all these developers check in their code to the repository. After the code is checked in, there is a CI, continuous integration and continuous delivery server. We use Jenkins as CI/CD tool. CI/CD, you can say, yeah, a tool. So there has to be someone when we say continuous. So there has to be a minimal or no manual intervention of any of the person in this whole complete life cycle of the SDLC, right? So there has to be automation everywhere. So there has to be someone automatically fetch the code. So if this person named Jenkins, he will sense that there's some kind of check-in that has happened to this repository. He will start building the code. He will trigger the build pipeline. Okay. Once he triggers the build pipeline, the artifact is generated. This artifact then, once the artifact is generated, there will be again a pipeline for continuous testing. As soon as this person knows as soon as this person knows here that there's a new artifact that is generated, it starts, or it automatically starts its testing. So we software testers write the test cases, or we also do it via different tools like Selenium. Once the testing is completed, the artifact is ready to be deployed to any of the environment. So it's not like that in uh, in companies. It's not like that the software will be deployed straight away to the production. First, it will be deployed to the lower environment. Okay, it will be deployed to the dev. Maybe you can say dev environment. Yeah, it can be deployed to the staging environment. Okay, and then after we are completed with all the testing on dev and staging environment, maybe then we can proceed with it to be deployed to the production and make it live for the end users. So the continuous deployment is there, right? And after this is deployed to the final server, it is our responsibility to create something called continuous monitoring, which can monitor the performance of our application so that we can get the feedback every time our how is our application performing. Okay, what is the how is it performing and how is it going on? Is there any kind of issues with the application? Is it live or is it down? So continuous monitoring should be there. Okay. Any questions so far? I'll take a pause for a minute.
No.
Okay. So we spoke about CI/CD in DevOps. The whole building block, or you can say main pillar of the DevOps is a CI/CD pipeline, continuous integration and continuous deployment pipeline. What is it actually? So continuous integration is the practice that generally uh, developers adopts whenever they are building their code. So every time there is a code change, okay, they have to commit the code to the source code management or centralized repository, and that code has to be built and tested, right, for the code quality, and then it has to be deployed. So this continuous process of continuously checking in the code to the centralized repository, building the code and testing it is known as continuous integration. Integration means integrating the source code. So it's not like only one developer sits in the company for a project and he writes the whole code. No, there are multiple team. There are multiple developers in which 15 to 20 developers work on a similar project. Someone might be developing the page outline. Someone might be developing the the color of the page. Someone might be developing the other part of that website. So at the end, they are working for a single project, but they are working for different modules, you can say. And once one module is completed, it is very mandatory for every one of them to integrate this code with the other developers module, because it's again a single website that they have to build. So what is the benefit of it? Suppose that I am a developer A, and I have today I have written the code for maybe menu items of pizza, and there's another developer B who has written the code for payment acceptance of that pizza website. So we both need to check in the code to the source to centralized repository, and our source code should not create bugs. If the bugs are created, then we have to sit together and fix those bugs, and then we again send it back to the source code management centralized repository for the for building purpose and testing purpose. So this happens on continuously day-to-day basis. That is why it is called as continuous integration of the source, right? How does this continuous deployment happen? So it is whenever there's a code change, right? So we have a new code check-in from the developer side. So the code is then needs to be built and tested. So and it has to be deployed. So once it is built on the CI server, continuous integration server, Jenkins in our case, we will using Jenkins. Okay, it the result of uh, that test has to go back to the developer, that if my source code is compiled well, does it contain any kind of bug, or everything seems to be good. Whatever it is, the result needs to be sent to the developer. After that, it has to be deployed to the environment, different environment. As I spoke about, there are multiple different environment on which the deployment happens of the single project. It's not that we make it live on the production system on the first go. We create environment like test environment, staging environment, and production environment, right? So so the artifact that we have generated will be deployed to the testing environment. After it is done in a, it is completed in the testing environment, maybe we will uh, move it to the staging environment. And after staging environment, all the results are passed. We will then make it live to the end users. So this is how continuous deployment happens. Okay. So this is how CI and CD works in DevOps. This is a brief introduction of DevOps and what do we achieve with DevOps. What was the drawbacks of waterfall model, agile model, how DevOps come into picture. So I think uh, enough for today as in demo session. We have gone through the overview. Do you guys need any? Uh, I mean, do you have any kind of queries, questions, anything you want to ask? Please feel
Yeah,
free to ask. Yeah. Yes, Chandan,
yeah.
please go ahead.
Hi, Gaurav. Yeah, I actually, I have issue with the timing. So if the time will be
Okay.
changed, then yeah.
So you're not comfortable with 9 to 10?
Yes, yes, correct. In because of second shift, I'm working
Okay.
a BT client. So
Okay. I think we can discuss with this with Lalit sir, and
okay,
maybe we can do some other shift timing. That is absolutely fine, no problem. Okay.
okay.
So guys, today was a theoretical part. I think and there was lots and lots of theories that I have spoken to you with you guys. So that is how it is, guys, because it's a very first lecture and it has to be theoretical part. So once we start the implementation, live implementation of all the tools of CI/CD, then there will be a lot more interest that will be there in the course, right? So today was the theoretical part. I can see that it there's nothing to be given as hands-on today. So maybe I would request you guys to go through CI/CD on the textbook side as well. Okay, do some research, maybe learn about CI/CD, learn about
Can you please
different
share this
models.
like PPT as well?
Yeah, sure. I think this model is sorry, this class is also recorded, so you should be having it.
Yeah,
Oh,
sure.
and I will be sharing it as well. Don't worry.
Yeah, thank you.
Okay. Any questions related to the course curriculum or any questions in your mind?
No, from my side here.
Okay. Okay, then I think I, there was one more guy who already left. So I think we are good to close today's session.
Yeah, sure. Thank you, Gaurav.
Okay. Thank you for your time. Chandan.
Yeah, thank you. Thanks a lot.
Thank you.
Bye.
Bye.